Hey guys, this one wasn't supposed to be a repair video. When I brought out this 386, it was really just to demo my new capture device. But then I powered the system on, and it didn't post. It's not the first time this computer's done this to me. So I figured this was a good opportunity to put a postcard in there and troubleshoot the issue. So when I power the system on, I'm getting dashes on the postcard. Now that indicates that the CPU is not executing any code. All the power rails appear to be okay, but we have two LEDs that are not on. And one of those is the clock LED. Now this postcard is actually giving me another very useful piece of information. I'm going to gloss over that for the moment. I'll come back to it later in the video, of course, but I want to bring you along on this journey exactly as it occurred to me. So we should see a bus clock on pin 20 of the ISA bus. That's usually around 8 megahertz. And then pin 30 should have a 14.318 megahertz signal as well. Now, I'm still a bit of a novice at motherboard repair, so I wasn't sure exactly which of these two lines that clock LED was indicating. So I'm going to check them both. If I use my logic probe on pin 30, it's not indicating the presence of the 14 megahertz signal. Now this logic probe can allegedly read up to 20 megahertz according to the manufacturer, so it really should be capable of reading that, if there's anything there. Now pin 20, on the other hand, shows a logical high signal. That should actually show as a changing signal. So clearly we've got something wrong on the bus. Now looking with the oscilloscope on pin 20, now we've got approximately 1 or 200 millivolts there, but there's no frequency, so really that just appears to be electrical noise as far as I can tell. Now I didn't check pin 30 with the oscilloscope. In hindsight, I really should have. I have a feeling, based on what I would later discover, that it probably had a healthy 14.3 megahertz signal. There are 3 crystals on a board of this nature. We've got the CPU clock. That's the 80 megahertz crystal down here. Now that feeds the 386 DX40 CPU with an 80 megahertz clock. That clock is actually cut in half in the CPU itself. That's why it runs at 40 megahertz. Then we have the real-time clock crystal. That's the little cylinder off on your left. Now that runs around 32 kilohertz. And then we have a 14.318 megahertz crystal. Now that's the one that should be generating a signal on pin 30 of the ISA bus. So I checked all 3 crystals, and of the 3, only the 14.318 megahertz crystal appeared to have any sort of issue. The solder joints on that crystal were very poor. They appeared to be cold joints, so I actually reflowed the solder joints on that crystal and powered the system back up. The system did boot normally. As you can see, we're in BIOS. But this is an intermittent issue. That may have simply been a coincidence that the system booted this time. So to test that theory, I decided to remove the 14 megahertz crystal. If indeed that crystal was the source of our issue, removing it should bring us back to dashes on the postcard. If I power up the system without that crystal, we're actually getting information on the postcard. You can see we've got a 0D code and a beep code as well. And of course the clock LED is on. Pretty safe to say that 14 megahertz crystal is not the source of our issue here. Now, while we're here, I'm going to check the ISA bus. Pin 30, of course, indicates no signal. That's to be expected since we've removed the crystal. And pin 20 indicates no clock. And putting the crystal back on the board, we're back to dashes on the postcard, and the clock LED is off once again. Now, it was at this point that I realized my mistake. I had kind of fixated on that clock LED as the primary source of the issue, when really it was only a symptom of another issue. Let's take another look at that postcard. The clock LED is not on, but there's another LED there that is on, and it really shouldn't be. And that's the reset LED. When a system first powers on, the CPU is held in reset status. After about 200 or 300 milliseconds, I believe, it comes out of reset and starts executing code. What's going on here? That CPU is not coming out of reset. Therefore, it's not executing code, and that kind of leads into the other symptoms that we're seeing here. When I realized that, everything kind of fell into place. When I first bought this case, it was a used case, of course. There was no motherboard in it, but I know for a fact the board that was in it initially had suffered a catastrophic battery failure. There was corrosion all over the power connector. Now, of course, I cleaned that up as best I could, and everything appeared to work properly. But apparently I didn't do a good enough job. The power good line on that power connector, that's the orange wire here, there was some corrosion left on that power good line, and it was making intermittent contact with the board. The motherboard would occasionally receive a signal that all the power rails were okay, and that it was safe to come out of reset mode, and sometimes it wouldn't. So after a proper cleaning and some deoxit, the system is stable once again. It fires up consistently with absolutely no problems. So I went down a bit of a wrong road with the troubleshooting on this one, but I think it was an interesting journey, and I learned a few things along the way. I hope you enjoyed it as much as I did. So, as always, feel free to like and subscribe, drop a comment down below, and thanks for watching.